Cloudflare's control plane loses power, a DevOps Postmortem. It's 11:43 UTC on November 2nd, and suddenly the lights go out not in an office, but in the very heart of the internet's infrastructure. For thousands of customers, the dashboard goes dark, the APIs start spitting errors, and analytics engines simply stop spinning. You're watching the nerve center of one of the world's largest networks vanish into a black hole because of a single utility power failure at a third-party data center. While the actual user traffic was still moving through the pipes, the engineers behind the curtain were suddenly flying blind, unable to see or manage their own systems. This wasn't just a glitch. It was a massive failure of high availability assumptions that left core services crippled for nearly 2 days. We aren't just talking about a minor hiccup here. We're looking at what happens when your redundant control plane turns out to have a single point of failure. Imagine you're running a massive operation where everything the buttons, the switches, and the internal dashboard used to steer the ship relies on one central brain. That was exactly what happened with Cloudflare's infrastructure back in November. To understand why this hit hard, think of their system like a city's electrical grid. The data plane keeps the lights on for everyone, but the control plane is the command center that lets engineers actually manage those lights. On November 2nd, starting around 11:43 UTC, a utility power event at a third-party data center triggered a cascading failure. While much of the user traffic kept flowing, the brains went dark. For nearly 2 days, the dashboard, API, and analytics tools were essentially bricked. It wasn't just an inconvenience. It meant thousands of customers lost the ability to see or change anything on their accounts, while the very heart of the platform sat offline. It was November 2nd, and for most of our users, everything felt like business as usual. The edge network was humming along, pushing massive amounts of traffic without a hitch. We had built systems designed to be resilient, but we were about to find out exactly where those assumptions hit a brick wall. At 11:43 UTC, a utility power event struck a third-party data center, the specific site housing our core control plane. It started small, a localized failure in the infrastructure layer that didn't immediately stop the flow of user traffic. But while the front door remained open, the keys to the kingdom began to vanish. Within hours, the dashboard, API, and analytics tools started dropping offline for a huge chunk of our customers. The God view was disappearing. We weren't seeing a total blackout yet, but the very tools we needed to manage the network were starting to flicker into nothingness. It started at exactly 11:43 UTC on November 2nd. It wasn't some elegant software bug or a rogue script. It was something far more visceral, a utility power event at a third-party data center. In an instant, the infrastructure housing Cloudflare's core control plane began to buckle under the weight of cascading failures. Within minutes, the first alarms didn't just chirp, they screamed. Engineers watching the monitors saw the dashboard go dark, while the API and analytics services vanished from view for a massive swath of customers. The irony was brutal. While much of the actual user traffic continued to flow through the network, the brains of the operation were effectively lobotomized. For those on the front lines, the reality set in quickly. The redundancy assumptions had failed. They weren't just fighting a glitch. They were staring into the void left by a single point of failure in their primary management hub. It started with a routine utility power event at a single third-party data center, but what followed was a textbook study in hidden dependencies. By 11:43 UTC on November 2, that localized failure began cascading through the infrastructure like a falling row of dominoes. Because the control plane relied too heavily on that specific facility, the ripple effect hit hard. The dashboard, API, and analytics tools suddenly went dark for a massive swath of customers. While the actual user traffic continued to flow, a lucky break for the end users, the engineers were left flying blind. For roughly 2 days, the management layer remained crippled because the failover mechanisms simply weren't designed to handle a total site loss. It wasn't just a glitch, it was a structural collapse where the assumption of redundancy failed exactly when the pressure peaked, leaving the team fighting to regain control over their own tools. So what actually broke? It wasn't a bug in the code or a rogue deployment, it was a fundamental architectural gamble that finally hit a wall of reality. The system relied far too heavily on a single physical location for its core control plane and analytics tools. When a utility power event struck that specific third-party data center on November 2nd, it didn't just flicker, it triggered a cascading failure. Because the infrastructure lacked true geographic diversity for these management layers, the failover mechanisms simply never kicked in. While most user traffic continued to flow through the edge, the brain of the operation, the dashboard, APIs, and analytics went dark because they were tethered to one spot. They essentially traded high availability for simplicity until the lights went out at 11:43 UTC, leaving them blind and unable to manage their own house for nearly 2 days. When the lights went out at that specific third-party data center, the blast radius wasn't just a localized flicker. It was a structural collapse of the tools we relied on to steer the ship. Starting at 11:43 UTC on November 2nd, the failure cascaded through the control plane, effectively blinding thousands of customers. While much of the actual user traffic managed to keep flowing, a lucky break in an otherwise grim scenario, the dashboard, API, and analytics suite vanished into a black hole. For roughly 2 days, engineers were flying blind, unable to modify configurations or see what their traffic was doing. It wasn't until November 4th that these core services finally stabilized. Even though the front door stayed open for most users, the loss of the cockpit meant any attempt to fix things mid-flight was impossible. It was a brutal reminder that when your management tools die, you're essentially steering by feel in the dark. At 11:43 UTC on November 2nd, the alarms didn't just chirp, they screamed. A utility power event hit a third-party data center hosting the core control plane, and suddenly, the lights went out in the command center. While the massive volume of user traffic continued to flow through the network, the internal tools were gutted. The dashboard was dark, the APIs were unresponsive, and analytics simply vanished into the void. For 2 days, the team was flying blind, fighting to stabilize systems that had lost their brains because our redundancy assumptions failed at the very first hurdle. It wasn't just a glitch, it was a total disconnect from the controls. We spent those 48 hours scrambling to manage a ghost ship while the realization set in. We'd relied too heavily on a single facility for something as critical as the control plane. By November 4th, services finally stabilized, but the war taught us exactly what needed changing. The fix wasn't some magic line of code, it was a hard pivot in architectural philosophy. While the primary goal was restoring access to the dashboard and APIs after they went dark following that initial power event on November 2nd, the real work started with dismantling their reliance on a single point of failure. They realized that while the data plane kept moving, the lack of management tools left them flying blind. To ensure this wouldn't happen again, they accelerated a high-priority project to distribute the control plane across multiple independent data centers. By decoupling these critical services from one specific facility, they ensured that no single utility failure could ever paralyze their internal operations again. It was a move from hopeful redundancy to actual, hardened infrastructure diversity. They stopped assuming a single site could hold the keys, making sure the lights stay on even when one building goes dark. Look, here's the cold truth we have to swallow from this one. Redundancy isn't a magic word you just type into a config file and call it a day. You have to actually test those assumptions against physical reality. The fact that the dashboard, API, and analytics vanished because of a localized power failure tells us that our control planes were far too cozy in a single footprint. Even when the data plane kept humming along, which is a win, sure, losing the ability to manage the system is still a massive operational blind spot. We saw what happens when a single facility becomes a single point of failure for the entire command structure. Moving forward, high availability means geographical diversity. If a utility provider flips a switch at one site, your team shouldn't be left flying blind. We need to build systems where no single building can take down the keys to the kingdom. That's how Cloudflare turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.